Assalamualaikum, my name is EMYLIA binti RAMLI and I'm from EH2203B. The assignment topic is Bernoulli's Theorem and I'm from Group 4.
Hi, my name is INTAN SURAYA binti Mohammad SHOKRI.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad from NAZIR from EH2203B.
Assalamualaikum. My name is Ainol Ruzana.
Firstly, I will present an introduction for this experiment, which is Bernoulli's Theorem. In fluid dynamics, Bernoulli's Theorem is relation among the pressure, velocity and elevation in a moving fluid, the compressibility and viscosity which are negligible, and the flow which is steady or laminar. Bernoulli's principle is named after the Swiss scientist Daniel Bernoulli, who published his principle in his book Hydrodynamica in 1738. Bernoulli's principle states that for an inviscid flow, an increase in the speed of the fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid's potential energy. Bernoulli's principle can be derived from the principle of conservation of energy. This states that the sum of all forms of energy in a fluid along a streamline is the same at all points on that streamline in a steady flow. This requires that the sum of kinetic energy, potential energy, and internal energy remains constant. In this experiment, we are using orifice in determining jet velocity, volumetric flow rate as well as coefficient of contraction. An orifice is an opening of any size or shape in a pipe at the bottom or side of a container which fluid is discharged. If the geometric properties of the orifice and the inherent properties of the orifice are known, the orifice can be used to measure the flow rates. Flow measurement by an orifice is based on the application of the Bernoulli's equation.
The next part is the theory of Bernoulli's theorem. In 1738, the Swiss scientist Daniel Bernoulli developed a relationship for fluid flow through a pipe of varying cross-sections. He proposed a theorem for the streamlining of a liquid based on the law of conservation of energy. Bernoulli equation formula is a relation between pressure, kinetic energy, and gravitational potential energy of a fluid in a container. P is represent of pressure, V is velocity, rho is density, and H is the height of the container. And next, we consider fluid in a tank which is open to atmosphere escapes through an orifice at a vertical H distance from the free surface of the fluid point 2, as shown in figure 1. Following the conservation of energy, the total energy at point 1 is equal to the total energy at point 2, which can be represented by the Bernoulli's equation as given below. The pressure at the jet and the top surface is therefore approximately equal to the atmospheric pressure, which is P1 is equal to P2. The fluid is assumed to be incompressible and therefore the density is constant. By taking the point where the fluid jets out of the reservoir, as the date and velocity at point 1 are extremely small, the Bernoulli equation can be further simplified as shown. In other words, at the right side of the slide, the equation predicts the velocity of the jet to be equal to the square root of 2gh. Measuring the velocity of the jet is quite challenging. However, it can be measured indirectly by tabulating the height of the water against the time elapsed. The rate at which the change is proportional to the velocity of which the water leaves the orifice, and note that the velocity is not constant. Therefore, the rate of H changes is proportional to the velocity. The equation is as below, which is dH over dt directly proportional to velocity. The next part is, what is the objective? The objective for this experiment are to determine the jet velocity as well as volumetric flow rate of fluid exiting the orifice of a water tank in the beginning of the experiment. and to determine the coefficient of contraction that is available in the system.
Okay, now I will be talking about the calculation. First, from the Bernoulli equation over here, it can be simplified into this equation. Why? Because P1 over here is equal to P2. Sorry for my bad handwriting, which means it can be cancelled. And next is the V1. V1 it can be cancelled also because V1 over here is extremely small, so it can be cancelled too. And then is Z2. Z2 is the term over here, which means it is 0, so it can be cancelled, and to form this equation. Why Z1 is equal to H? Z1 is over here, which means Z1 is the height of the water level from the orifice, so Z1 is equal to H. In other words, velocity is equal to the square root of 2gh. After that, substitute the value of v into this equation to get this, and to solve this equation we are needed to integrate h toward the h, which means we are gonna need to bring h to the left side and the others are to integrate towards dt. After all the integration, we will get this equation, and if you notice that there is a constant over here. Why? Because we didn't put the upper or the lower limit. Next, to solve the value of c at t is equal to 0, substitute the value of t to finally get the value of c, and after that finally substitute the value of c that we get from here to finally get this equation. Next, from the data of the experiment, from this data, plot a graph of time versus height in Excel, and then the Excel will automatically generate this equation for you, which we can use this equation to find the value of beta from the first equation that I've shown you.
Next, to find the beta, we must comparing the equation 4 with the quadratic equation that we can get from our graph, which is equation 5. By comparing this beta in terms of t squared, we can get our coefficient contraction. As we know, the coefficient contraction is equal to beta, and the value of coefficient contraction is 0.01628. Then we proceed to find the velocity by using the equation that we had derived earlier by substituting the gravitational and height that we can get from our table. And the velocity is 2.0586 meter per second. And lastly, to determine the volumetric flow rate, we must use the equation of Q is equal to area of bottle multiplied by velocity. So the value of volumetric flow rate is 0.01224 meter cube per second.
Hi, next I will be talking about the methodology or the procedure of this experiment. First, take an empty bottle and make sure that it is empty. Next, by using the marker and the ruler, measure from the bottom of the bottle the length of 2.5 cm and mark it. After that, heat up a screw, add a heat source, and then push the hot screw through the plastic bottle to make a small hole or orifice at the mark point. Cut the upper part of the plastic bottle and measure Then record the diameter of the plastic bottle and the orifice. Close the small hole by using a sellotape and fill in the plastic bottle with water. Add a few drops of food coloring to make the water more visible. Measure and record the initial height of the water level from the orifice. Ready the stopwatch. And then let the water to flow out and measure the height of the water level every 5 seconds.
The experiment was conducted to determine the value of jet velocity, volumetric rate of fluid, and at the same time to find the coefficient of contraction available in the system. The experiment is conducted with the assumption that the pressure is constant, the fluid is incompressible, the density is constant, and V1 is very small, therefore it will be neglected. To achieve our objective, the experiment was conducted by making a hole at the side of the bottle to act as an orifice, and the bottle is then filled with water. The height of water level is measured and recorded for every 5 seconds with the initial height of 0.2160 meter. In accordance to the result collected, a graph of water versus time is plotted. In accordance to the graph plotted, it shows that height is inversely proportional with time, given that the rate of height dh/dt is directly proportional to velocity. Thus, the velocity is inversely proportional with time. From the equation of Q equals to AV and the equation of kinetic energy of 1 over 2 mv squared, it can be seen that Q and kinetic energy is directly proportional with velocity. Therefore, it can be deducted that Q and kinetic energy is inversely proportional with time. That highlights the fact that as time increases, Q will decrease, and at the same time kinetic energy will also decreases. The main purpose of this experiment is to determine the coefficient of contraction, which will be calculated by comparing two equations obtained from two different methods. The first method is the derivation method, which will give us an equation with H as a subject, while the second method, the graphical method, will give us an equation with Y as a subject. Both equations will be analyzed and compared, and the value of B will be calculated. B is defined as the coefficient of contraction will measure the ratio of vena contracta and the area of the orifice. Therefore, it can be seen that in order to control the coefficient of contraction is by controlling the size of orifice or by controlling the size of the tank.
This element of sustainability. The three components of sustainability are the environment, the economy, and the community. When conducting this experiment, we observe that there are some element of sustainability that can be detected. For instance, there is an element of environment. We decide to use recycled plastic water bottle as the tank for this experiment. It can also be shown when we decide to use recycled water aka clear water for the experiment. There are few modifications and recommendations that can be considered while doing the experiment in order to get more accurate result and improve overall conduction of this experiment. The overall apparatus used in this experiment is not suitable, which will lead to the inaccuracy in the result taken. For example, there might be some water leakage when closing the small hole by using the sellotape, which will disturb the water level reading. Next, the recommended device used to measure time is a stopwatch, not a smartphone. Therefore, this will cause an inaccuracy for the reading for the time. Therefore, it is recommended to use actual and proper lab equipment to conduct such experiment.
The experiment was conducted in order to determine the value of jet velocity, volumetric rate of fluid, and also to find the value of coefficient of contraction available in the system in accordance to the result graph. And also calculation, the value of coefficient of contraction was able to be obtained, which is 0.01628. From the value of beta, we were able to obtain the value of jet velocity by using the equation of v squared equals to square root of 2gh. The value obtained is 2.0586 meter per second. Lastly, we were able to calculate the flow energy with this equation. The value obtained is 0.1224 meter cube per second. More specifically, the experiment was done in order to see the relationship between flow energy, kinetic energy with time, which based on the result and the graph plotted, we were able to conclude that as time increases, Q will decrease, at the same time kinetic energy will decrease. Other than that, the experiment was executed to establish the fact that we were able to obtain coefficient of contraction by the derivation of Bernoulli equation with the consideration of initial height and the graphical method of graph of water versus time. Both of this method will give us an equation which will compare, and then we can calculate the value of beta. We also established the fact that the coefficient of contraction is controlled by the size of the orifice and the size of the tank. Nevertheless, we succeed in obtaining the value of coefficient of contraction, jet velocity, and also the flow energy. Other than that, we were able to analyze the relationship between those obtained value. In conclusion, the objective is achieved.